Now, you'll learn about surfaces in Civil 3D, what they are, how they are built, and where and why they are used. You'll learn about the importance of break lines in the surface. We'll show you the differences between triangulation surfaces and grid surfaces. You'll learn about surface styles, labels, and tables. And we'll show you how volume surfaces can be used to calculate earthworks cut and fill. Surfaces are used in Civil 3D to create a 3D representation of the ground. They are made up of triangles or grids, which are formed by joining up 3D points or adding 3D lines such as polylines or feature lines. A typical project will require a model of existing conditions. We generally create an existing ground surface from topographical survey information, so we have a model in 3D we can base our design upon. Whilst we use surfaces to represent our original ground, we also create surfaces for designed ground forms such as ponds, building pads, car parks, and RD surfaces. Grading groups in Civil 3D provide criteria-based grading design that creates surfaces automatically. We also use surfaces directly for designing on. In this example, we're creating a surface profile to display in a profile view. The profile is dynamically linked to the ground surface and will update if either the route of the road or the surface elevations have changed. Once we have a profile view drawn in the model to display the profile, we can lay out the proposed vertical design for the road using the surface profile to guide our design. A tin surface is made up of triangles and can be created using different types of data. TIN stands for Triangular Irregular Network. Points and contours often provide the primary data used to create surfaces, with break lines used to control the formation of the triangulation. Break lines are ground features such as the top or bottom of an embankment, edges of roads, ditches, and so on, and will reorganize the triangles in the surface so that the triangle sides are aligned with the break line, providing a more accurate surface representation. A grid surface is created by importing DEM files or digital elevation model files, which are typically a grid of heights scanned from an aircraft, sometimes called LiDAR data. This type of data is widely and often freely available and is useful to provide us with large areas of surface where conventional topographical survey would be too costly or difficult. The DEM file contains a regular grid of elevations, and large surfaces can be generated very quickly. They're considered to be a type of raster data, like an image, with each pixel being an elevation. These large surface files can be used in our models to provide context for our design and are useful for creating visualizations of our projects. We can create surfaces from our designed RD corridors. These are tin surfaces that are linked to the corridor, and they are built by adding links and feature lines from our assemblies and the corridor model that uses them. When a corridor is edited, the surface will update automatically. We will often create a top surface for our road to show contours of the finished RD surface and for visualization. We can also create a formation or datum surface from our corridor that shows the depth of construction for the road, and we can use this to calculate earthworks cut and fill. The display of a surface is controlled by its style. Surface styles can be applied to view surface contours with different intervals. For example, the style controls which components of the surface points, triangles, contours, elevations, or slopes are displayed, and they can be set independently for viewing in plan or in 3D. We can also use stars to analyze a surface. In this example, we are analyzing the surface by height range. The surface style allows us to understand information about the surface without direct interrogation. Legend tables provide further information about our surfaces. Like most other Civil 3D objects, we can add annotations to our surfaces using different label styles. Elevation labels provide height information at important locations and are useful when we're producing our construction documentation. contour labels can be added across a surface so that we can interpret the surface contours quickly. All of these labels are dynamic and will update if our design surfaces change. This is important as it means we can produce documentation earlier in the project lifecycle and we don't have to worry about out-of-date information. The format of our labels can be swapped easily. These slope labels are being added either as a slope of 1 in X or as a percentage gradient on flatter slopes. A special type of surface, called a volume surface, is used to compare two surfaces together to calculate volumes of earthworks cut and fill. Unlike a normal tin surface, a volume surface is built from depths, not elevations. These values are derived by subtracting a base surface from a comparison surface. Individual volume surfaces can be combined to give a complete site volume. We can use volume surfaces from different design objects to balance the whole site cut and fill. Volume surfaces contain the information about their depths and volumes. This information can be used to produce a surface analysis of the cotton fill or isopack sites, as they are sometimes called. Here we're using a surface style that can be analyzed to produce red and green depth bands representing the areas of either cut or fill. Adding a legend table can provide the empirical information we need to make sense of the surface display. This type of information can be invaluable for construction planning. Now that you have seen how you can build surfaces in Civil 3D and how they can be used, you are ready to explore the options for creating your own existing and design surfaces. Now you'll learn how to build an existing ground surface. We'll add data to the surface using points, polylines, text, and contours, and you'll learn about weeding and supplementing data when using contours. From the Iowa City 02/07 Project Design Models folder, open the Drawing Building Existing Ground Start. We're now going to start building our existing ground surface from project data that we've acquired from a variety of sources. This existing ground surface will be the base drawing for all of our site design from this point onwards. In this drawing, we have the Survey Points point group, which was created from our Survey Point file. We also have some contours, which have been extracted from a DEAN model from the U.S. Geographical Survey data. These are just lightweight polylines with a height. To create a new surface, we could use the Home ribbon tab and on the Create Ground Data panel choose Surfaces and then Create Surface. However, we are going to use Prospector to create our surface since this provides easy access for everything that we need to do. In Prospector, right-click on the Surfaces collection and choose Create Surface. This surface will be a tin surface made up of irregular triangles. Override the default name and rename it to Existing Ground. It's good practice to give your Civil 3D objects names that your coworkers will understand. You can enter a description. If required, set the surface style to Contours 1 foot and 5 foot design. This will show colored contours at 1 foot intervals. Click OK. We've just created a new empty surface. Now we need to start adding data to it. We can add data to a surface using the ribbon. On the Modify Ribbon tab, from the Ground Data panel, choose Surface. Then on the Surface Ribbon tab, from the Modify panel, there's an App Data button which can be used to add data of different types to the surface. We can also add data to our surface using the Tool Space Prospector tab. Expand the existing ground surface. In the Surfaces collection, expand the definition item. Here you'll see all the different methods of adding data to the surface. First, we're going to add our COGO points. Right-click on Point Groups, select Add, and from the list of point groups, choose Surveyed Points and then click OK. You'll see the data has been added to the surface and the surface is displayed in the model space as contours. Now we're going to add the contour polylines to the surface. This is going to provide less accurate surface data around the immediate site boundary, but we can use this additional area of surface to provide context to our project. Select the Contours item, right-click and choose Add. Enter the description contours from DEEM. Each contour will have a lot of vertices along the line, and this will subsequently generate a large number of triangles in the surface, which could affect the performance of our models. We can adjust the number of vertices that are added from the contour polylines using the weeding and supplementing factors. The weeding factors control the removal of points from the contour. If the distance between vertices on two line segments is less than the weeding distance, then provided the deviation of line segments is less than the weeding angle, the middle vertex will be deleted. Supplementing factors control the insertion of interpolated points to ensure similarly sized triangles are created. If the distance between two contour vertices is greater than the supplementing distance, then additional vertices are added. If the contour lines are curved, then additional vertices may be added around the curve so that our surface triangles will match the contour more accurately. If the mid-ordinate distance of the curved segment between two vertices is greater than the supplementing mid-ordinate distance, then additional vertices are added so that the separation of surface triangle sides are now curved will match the specified mid-ordinate distance. In the Minimize Flat Areas, by section select Swapping Edges. This ensures that triangles will be rearranged to prevent triangles from spanning a single valued contour and thus creating a flat triangle. Click OK, and in the model space use a crossing window to select all of the contours. Press Enter to accept the selection. The contours are now added to the surface definition. We can't delete the original polylines as this will delete them from the surface, so to prevent us selecting them again by accident, we'll turn off their layers. From the Home ribbon tab on the Layers panel, click on the Layers pull-down list and turn off the layers 0 Deem Contours Major and 0 Deem Contours Minor by turning off the light bulb icon. We're now going to add some break lines to our surface to improve the surface definition. When we add break lines to a surface, Civil 3D will retriangulate the surface to ensure that our surface triangle sides lie along the break line and don't cross it. From the Insert ribbon tab, on the Block panel, choose Insert and select Blocks from Libraries. Add a new library by picking the Add Library button. Navigate to the Civil 3D Projects folder, Iowa City February 7th, and then the O2 Base Data folder and click Open. From the library now displayed, we're going to insert the 3D break lines drawing. First, ensure that none of the insertion options are selected. Right-click on the 3D break lines drawing and choose Insert and Explode. The break lines are inserted into the drawing. These are 3D polylines representing surveyed features on the ground. In Prospector, select Break Lines from the existing ground definition. Right-click and choose Add. Enter a description of 3D survey. There are two main types of break lines, standard and proximity. We use standard when our break lines are 3D and we want to add the break line heights to the surface. We use proximity when our break lines are 2D polylines. In this case, Civil 3D will ignore the Z value of the polyline and only use the XY position of the line to control the triangles. Ensure the break line type is set to standard and click OK. In the model space, use a window crossing to select all of the break lines and press Enter to accept the selection. The break lines will be added to the surface and the contours will update. The event viewer may be invoked by alerts triggered during the surface rebuild. You can review warnings in the event viewer and zoom to specific issues to review them. Some break lines have not been added where they cross another break line. Close the event viewer. We're now going to add some additional survey information from a 2D survey drawing. From the Insert Ribbon tab Blocks panel, select Insert, then Blocks from Libraries. Select the 2D survey drawing, right-click and choose Insert and Explode. The 2D survey has text values to represent the survey levels. These have no Z value, but the contents of the text provides us with the required elevation. We can raise these text items to their correct Z values. Select one of the text values, right-click and choose Select Similar. From the Modify Ribbon tab, Ground Data panel, choose Surface. From the Surface Ribbon tab, Surface Tools panel, select Move to Surface, then move text to elevation. The selected text objects will be given Z values based on their text contents. Back in Prospector, under Existing Ground and Definition, select Drawing Objects. We use this method when we want to add data to our surface that's represented by existing AutoCAD entities. Right-click and choose Add. From the list of types, choose the text filter. Type a description of 2D level text. In the model space, use a window crossing to select the area of 2D text. Press Enter to accept the selection. Again, the surface will update with the new information we have added. We're now going to add the 2D features as break lines. In Prospector, select Break Lines, right-click and add Type a description of 2D survey. Set the break line type to Proximity since we don't want to use the elevations of the lines and the surface, and click OK. Use a crossing window to select all of the polylines in the 2D survey and press Enter. Close the event viewer if it appears. The result of adding the 2D break lines can be seen on this embankment where the contours now run along it. Now that we've added our different data sets to the surface, we can review it. Select the surface by clicking on any contour, right-click and select Object Viewer. We can see in the 3D view that there are some mistakes in the surface which we'll need to correct. We've now created our existing ground surface, and our next task will be to edit the surface to correct any errors. Now, you'll learn how to edit a surface by setting the surface build options. We'll use the surface style to display points and triangles and then delete points from a surface. We'll swap triangle edges to manually re-triangulate the surface and use proximity break lines to automatically re-triangulate the surface. And we'll use the surface operations list to remove a surface operation and reorder surface operations. From the Iowa City 02/08 project. Design Models folder. Open the February 8 surface editing, start drawing. We have built our existing ground surface using various data sources, including topographical survey information. However, some of the information we have used has caused some errors in the surface formation. A good way to locate surface errors is to display the surface as contours. Where contours are closely packed together, it's a good indication of points in the surface with incorrect levels. We're now going to edit our existing ground surface to fix some of the errors in the surface. From the View ribbon tab on the Named Views panel, restore the view area 1 using the Restore View pull down. We can see the contours are very close together around this point in the surface. This point was created when we added text entities to the surface. This text is a tree label and doesn't represent a height on the ground. When we run the command Move Text to Elevation, Civil 3D couldn't convert this text to a z value, and so it remains at 0. This has resulted in a 0 elevation in our surface. We could remove the text entities from the surface, delete the tree labels, and then add the text again. But we have an easier way to fix this problem. Select the surface by picking on the contours. And on the Surface Contextual ribbon tab, select Surface Properties. In the Surface Properties, on the Definition tab, expand the Build options. These are settings that control how a surface is built, and we can edit them at any time for each individual surface. We have a setting to enable us to control the elevation range in a surface. Click in the Value column of Exclude Elevations Less Than and set it to Yes. In the Elevation Less Than column, set the value to 0.01 feet. This will exclude all zero-value elevations. Click OK and rebuild the surface. You can see that the surface has been corrected and the contours are displayed. On the View ribbon tab, restore the view area 2. Here we have a similar problem, but this time the elevation text values are wrong and are displayed in meters. We're going to fix this error by deleting these points from the surface. Select the surface and from the Contextual ribbon tab select Edit Surface and then Delete Point. Civil 3D displays a message telling us that there are no surface points displayed for us to select. It suggests that we edit the surface style and try again. With the surface still selected, right-click and choose Edit Surface Style. This will take us into the Style Editor for the style currently in use. On the Display tab, edit the plan, view direction and turn on points and triangles. Click OK. The surface points and triangles are now displayed. Zoom into the elevation value on the left. Select the surface and on the Ribbon tab choose Edit Surface, then Delete Point. Pick the blue cross for the first surface point to be deleted. Then pan across and select the second surface point. Press Enter to accept the selection. The points are deleted and the surface will update. From the View ribbon tab, restore the view area 3. Here the problem with the surface is a bit more subjective. The contours appear to be pulled sharply in one direction along this highlighted triangle side. We're going to improve the surface by swapping edges. Swapping edges is the process of flipping the common side between two adjacent triangles. The result of this edit can make a dramatic change to the surface. Select the surface, choose Edit Surface on the Surface Contextual ribbon tab, and then swap edge. Pick the triangle side to be swapped and the triangle will update. Press Escape to end the command. Now restore the view area 4. Here we have a similar problem, but this time we have multiple triangle sides to swap. We're going to do this by adding a break line to the surface. Draw a polyline between the 2 points shown without snapping to anything. Drawing close to the points is good enough. In Prospector, expand the existing ground surface and expand its definition. Select Break Lines, right-click and Add. The break line we're going to add is a 2D polyline, so set the break line type to proximity. A proximity break line only needs to be close to the surface points. The break line will be applied to the closest points to the line. No heights are added to the surface, but the break line will realign the triangles. Click OK, then select the polyline and press Enter. Review the changes to the surface. Finally, select the surface and go to the Surface Properties. On the Definition tab of the Surface Properties, the lower half of the dialog shows the operations list. Civil 3D saves a history of all operations and edits made to the surface. Here we can undo and redo operations to the surface. Deselect the Add Contour Data operation. Click OK and rebuild the surface. You can see that the contour data we added to the surface has now been removed. Go back to the Surface Properties and in the Operations list reselect the Add Contour Data. Click Alley and rebuild the surface. The contour data is added back into the surface. Using the Operations list, we can remove an operation permanently. We can also select operations, and using the arrow buttons on the side, we can change the order of operations if we need to. We've now explored some of the options for editing a surface, and we have fixed some of the mistakes in our existing ground surface.